since we met, right? My machine had an issue, guys, but it has been adjusted and I'm now on board, guys. We are ready now to go. All right, so friends, please subscribe to this channel if you want to have more great content from us, guys. Like the video, please share it out with others so that they can have access to great content like this that is going to benefit them in their own exams. I am Omenju Macarius, guys. This is Humble Mark Academy. Let's get started, friends. Perfect, friends. Let's say that we have a function defined as y equals f of x, which is given as x to the power n. Therefore, guys, according to the first principal method of differentiation, it is saying that our f prime of x, which is the first derivative of y with respect to x, that's the first derivative of f of x, f prime of x, is given as the limit as h goes to 0 of f of x plus h minus f of x, all this over h. So, guys, this is simply the definition of the first principal method of differentiation. Okay, if we apply this same principle now to this our function x to the power n, we are going to have our f prime of x, guys, being the same as the limit as h goes to 0. F of x plus h is simply got by replacing where we have x here with h, so we are going to have x plus h raised to the power n minus f of x, guys, is a function x to the power n, right, all over h. So, guys, if you simplify this further a bit, we are going to have f of x be the same as the limit as h goes to 0. We have x to the power n. How do we get x to the power n, guys? You notice that if you factor out x in this interior, we are going to have x into 1 plus h over x, right? Everything raised to the power n, so the n can distribute itself. We have x to the power n into 1 plus h over x raised to the power n minus x to the power n over h squared. Okay, now, guys, at this point now, you simply discover that we have x to the power n here, right? X to the power n, so we can factor that further. We do that, we are going to have the limit as h goes to 0. We have x to the power n into, we have this 1 plus h over x raised to the power n minus 1. If you multiply this out, guys, you have the same quantity. Okay, now, guys, at this point, let's simply recall the binomial theorem. What the binomial theorem is saying. The binomial theorem, guys, is simply saying that if you have a function defined as 1 plus x to the power n, the series expansion for this is the same as 1 plus nx plus n into n minus 1 over 2 factorial x squared plus dash dash dash, guys. It keeps on going in the same pattern, meaning that the next term is going to be n into n minus 1 into n minus 2 over 3 factorial x cubed and so on, guys. But, friends, this is an infinite series, so we can simply say that this is equal to this. Okay, now, guys, you notice that what is so particular in this our expansion is what? 1, right? We need to have a 1 here, which is exactly what we have here, right? Because our goal is to express the quantity in blue here, guys. We want to express the quantity in blue here using the binomial expansion. Great. So, guys, if we do that now, we see that our x in this case is what? Is h over x, right? Our 1 remains 1 and our n remains n. So if we try to express in a similar manner, guys, simplifying, we have the limit as h goes to 0. X to the power n is outside. Then the quantity in blue, 1 plus h over x, we can express it like how we have done this in the same form as n. That's as nx. Our x is h over x plus n into n minus 1 over 2 factorial. X is simply what? H over x. Squaring that, we have h over x all that squared plus dash dash dash. Guys, don't forget we have a minus 1 here, right? So we have the minus 1. But, guys, what do you notice? 1 and minus 1, they can cancel, right? So we're going to have the limit as h goes to 0 of, now when this 1 and minus 1, they can cancel, right? We have an h here, right? That is when 1 and this guy, they must have gone. We have an h, we have h squared. The next term becomes what? H cubed, and so on and so forth, right? And we can also express this x in the denominator as x to the power negative 1. Meanwhile, we factored out the h outside. So this is what we're going to have now, friends. So, friends, what do you notice that as if we simplify for that, guys, we're going to have this, right? Because this h here can cancel with the h here. They can both cancel, so we no longer have h again on the denominator. So this is what we have now. So, guys, what do you score that as h goes to 0? This term has h, right? It goes to 0. The next term has what? H raised to the power 2. It also goes to 0. So this term as well goes to 0. Likewise, all subsequent terms after this term will likely go to 0. So we are going to have just the limit. We are going to have just our f prime of x, which is defined as what, guys? This limit, right? Being equal to n x to the power n minus 1, where we multiply x to the power n and n x to the power negative 1. We are going to have n x to the power n minus 1 as required, guys. So we can therefore conclude that if you have a function defined as y equal to f of x, which is equal to x to the power n, then the derivative of y with respect to x, friends, is simply defined as dy by dx being equal to f prime of x, which is equal to n x to the power n minus 1, guys, as required. Great. So guys, don't forget to like the video, friends. Please subscribe to the channel if you want to have more great content from us. Have a blessed day, friends.